Hello children, welcome back to your 7th standard mathematics class. I hope you all enjoyed your Diwali holidays. We'll start our second term from lesson number 13, the Pythagoras Theorem. You are very familiar with the name Pythagoras. Pythagoras was an ancient Greek philosopher. He was born in 570 BC in Samos, Greece, and died in 495 BC. He was credited with many discoveries in the field of science, mathematics, music, astronomy, and medicine. The discoveries done by him are Pythagorean or the Pythagoras Theorem, Pythagorean tuning, theory of proportions, sphericity of the Earth, the identity of planet Venus, and 5 regular solids. He also divided the globe into 5 climatic zones. People of many countries had long known of a certain principle related to right-angle triangle. As Pythagoras was the first to prove the theorem, it is named after him. Let's have a look into the components of a right triangle. In geometry, the right angle is an angle that makes an angle of 90 degrees. In triangle ABC, angle A is a right angle. A triangle with one right angle is called a right angle triangle. Base. It's a side of a right triangle that is adjacent to the perpendicular and the hypotenuse. In triangle ABC, AB is the base. Perpendicular. It is a side of the triangle that is adjacent to the base and hypotenuse. It is called the height of the triangle. In triangle ABC, AC is the perpendicular. Hypotenuse. The side opposite to the right angle is called the hypotenuse. In other words, the longest side of the right triangle is called the hypotenuse. In triangle ABC, BC is the hypotenuse. Pythagoras or the Pythagorean theorem. Pythagoras theorem is based on right angle triangle or right triangle only. The theorem states that in a right triangle, the sum of the square of the base and the perpendicular is equal to the square of the hypotenuse. That is, for any right triangle with sides A and B and hypotenuse H, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So we can write H square is equal to A square plus B square, where A and B are the lengths of the sides of the right triangle and H is the length of the hypotenuse. Now with reference to the figure, the theorem of Pythagoras can be written as follows. In triangle ABC, AC is the hypotenuse. So we can write length AC square is equal to length AB square plus length BC square. So we can state the theorem as hypotenuse square is equal to base square plus height square.
Now let's verify the Pythagoras theorem using an activity. Here I have cut out 8 identical right-angled triangles. Let us say the length of the hypotenuse of these triangles is A units and the sides forming the right angle are B and C units. The area of the triangle is half base into height. That is, the base is B and the height is C. So we have the area of the triangle as BC by 2. Now I have made two squares ABCD and PQRS. The two are identical squares and the side of each square is B plus C units. Now I am going to place the 4 right triangles on square ABCD and the remaining 4 triangles on the square PQRS. We have arranged the right triangles in the two squares. This length is C and this length is B. This distance is B and this is C. We have taken the measure of the hypotenuse as A units. So each of these hypotenuse becomes A units. So if you observe this figure, In figure number 1, we can see a square of side A units in the uncovered portion of the square. In figure 2, we see a square of side B and another of side C in the uncovered portion of the square PQRS. Now in the first figure, the area of the square ABCD will be the sum of the area of the uncovered portion plus the area of the 4 right triangles. The uncovered portion is a square here. So what is the area? It is A square. So you get A square plus the area of 4 right angled triangles. We had seen the area of one triangle is BC by 2. So the area of 4 triangle becomes 4 multiplied by BC by 2. We can cancel the 2 and the 4. 2 one time and 2 2s are 4. So we get the area of the square ABCD as A square plus 2BC. Now let's see the area of the square PQRS. In the second figure, area of square PQRS will be the sum of the square with side B, the square with side C, and the area of 4 right angle triangles. The area of this square becomes B square. The area of this uncovered square becomes C square. And the area of these 4 triangles becomes 4 into BC by 2. So we can write here B square plus C square plus 4 into BC by 2. Cancelling the 2 and 4, we get B square plus C square plus 2BC. The two squares ABCD and PQRS are identical squares. Therefore, the areas will be same. Area of square ABCD is equal to the area of square PQRS. That is A square plus 2BC is equal to B square plus C square plus 2BC. Area of square ABCD, we got it as A square plus 2BC, and area of square PQRS, we got it as B square plus C square plus 2BC. We can cancel the 2BC on both the sides, so we get A square is equal to B square plus C square. What is A square? The hypotenuse. And what is B and C? The sides of the triangle. So we have proved the Pythagoras theorem that the square of the hypotenuse is equal to the sum of the squares of the other 2 sides.
Let's see an example. Using Pythagoras theorem, find the value of A. Let's take the hypotenuse as C. So we can write C square is equal to A square plus B square. So A square becomes C square minus B square. Substituting the values of C and B, we get 13 square minus 12 square. 13 square is 169 and 12 square is 144. So we get A is equal to square root of 25. Square root of 25 is 5. So the length A is 5 units. This is another example where you will apply Pythagoras theorem. Here we want to find the length of the ladder, which is leaning against the wall of the house. The height is given and the distance between the base of the ladder and the base of the wall is given. So knowing the two distances, we can find the length of the ladder using the Pythagoras theorem. Other applications of Pythagoras theorem. The Pythagoras theorem has far-reaching ramifications in other fields such as arts as well as practical applications. The theorem is valuable when computing distance between 2 points such as in navigation and surveying. Another important application is the design of ramps. Ramp designs for handicap accessible sites and for skateboard parks are very much in demand. You will be studying more applications of the Pythagoras theorem in your later classes also. We'll be solving more sums based on the Pythagoras theorem in the next video. Please complete the activity on page number 87. Thank you and have a nice day.